Hello and welcome to the explanation and demo video of the Real Estate Price Predictor Linear Regression Model project. This is an educational project to showcase how machine learning is applied to a dataset of private real estate transaction prices to create a linear regression model. The model is coded in Python and executed on Jupyter Notebook. The model's parameters are then exported for use in the Maya Properties chatbot project. Let's look at the theoretical concepts. The first concept is linear regression. In simple terms, linear regression is finding the best fit line through a set of data points. The assumption is a linear relationship between the independent variable, x, and the target variable, y. This relationship can be expressed as y equals to m times x plus e. M is called the model's coefficient and c, the model's intercept. Mathematically, linear regression can be extended to multiple independent variables, such as x1, x2, to xn. The best fit line becomes the optimal hyperplane through these data points in high-dimensional space. The model parameters become the coefficients m1, m2, to mn, and intercept c. The second concept is machine learning. Applied to linear regression, machine learning refers to the process where the computer algorithm locates the parameters of the best fit line or optimal hyperplane. Machine learning is the traditional part of artificial intelligence, as against a more recent buzzword of deep learning. Broadly, machine learning algorithms refer to techniques applied on datasets in which we have domain knowledge into the relevant features and their underlying relationship with the target variable. In our current case, we apply the machine learning linear regression algorithm on the real estate prices dataset to obtain the model coefficients and intercept of the optimal hyperplane. The third concept is one-hot encoding. As computers handle only numerical data, we need to convert categorical data into numbers. For instance, in our real estate use case, the property types are apartment, condominium, bungalow, and so on. One way is to assign a running number to each category, like an index. This is, however, not effective, because a larger number skews the model unnecessarily towards that category. A better way is one-hot encoding. It entails creating a dummy variable for each of the features categories. Each data record therefore becomes a vector of mostly zeros, and a single one corresponding to its category. Although this results in multiple dummy variables, the resultant matrix is sparsely populated with mostly zeros, so it remains easy for computer processing. Let's look at the real estate prices dataset. The dataset comprises about 66,000 actual private property transactions in Singapore over 3 years from 2017 to 2020, published by the Singapore Urban Redevelopment Authority. Each data record has about 20 parameters relating to the transactions such as sales date, price, address and location details, type of property, tenure, property area, completion date, and so on. Let's look at the feature selection. It refers to picking up the useful parameters from the dataset. We apply two criteria to the feature selection process. Firstly, to apply the linear regression model, the assumption is a linear relationship between the target variable, which is transaction price, and one or more of the other parameters. Secondly, since we are deploying the model to the Maya Properties chatbot, we want to limit the features to a small number of those with the largest impact on the transaction price. Like most machine learning projects, our feature selection process is a combination of domain knowledge and trial and error. We make certain assumptions and, if correct, the resultant model is accurate when we test it. On the other hand, if the resultant model is not accurate, we need to go back to the drawing board and change the assumptions. It can be changing the machine learning algorithm or changing the selected features. In our case, we select the target variable as the transaction price per unit area, and 4 independent variables or features. The first feature is property locality, which comprises about 30 districts in Singapore. The second feature is property type such as bungalow, apartment, condominium, or terrace. The third feature is area type, whether landed or strata title. The fourth feature is tenure, whether freehold or leasehold. Let's look at the Jupyter Notebook and Python code. The first step is to import the pandas library, which is useful modules for data manipulation and for converting datasets into number matrices, suitable for downstream machine learning algorithms. We then load the real estate dataset into a pandas data frame object. We can display a sample of data records and the main characteristics of the dataset, such as the total number of data records of 66,786 and the 21 different parameters. The next step is to extract the parameters of our interest, namely, the price per unit area and the 4 identified features. We can display a sample of data records with these reduced parameters. The next step is to convert the data type of unit price from string to floating point format. We then separate the unit price, which is the target variable, and the features, into 2 matrix data frames. The next step is to apply one-hot encoding on the categorical data. All the features like locality and property type are categorical data. One-hot encoding is easy to implement in Python using the pandas library command, getDummies. This is automatically applied on all 4 of the categorical features. Once the 2 data frames of unit price and 4 features are ready, we can train the machine learning model. We first import the necessary modules from the sklearn library, including the train test split, linear regression algorithm, and the confusion matrix and R-squared performance evaluation modules. The dataset is split into 80% training data and 20% testing data. The model is then trained and evaluated using the testing data. The trained model gives a R-squared value of 61%. It means that the model can account for 61% of the variations in the unit price target variable. The remaining 39% of price variations cannot be explained by the model. This could be due to insufficient features or a more complex underlying relationship between the unit price and the features. We can use the sklearn export module to output the trained model parameters of the linear regression coefficients and intercept in JSON format for subsequent use in the Maya properties chatbot. Finally, we can use matplotlib-python module to visualize the predicted versus actual prices. If the model is perfect, all points will lie on the 45 degrees y equals to x line. Instead, the points spread out, but still lie roughly around this line. This is a visualization of the 61% R-squared model accuracy. All the Python code and slides are available at my GitHub folder. The link is at the video description. Have fun with Python coding. Thanks for watching. You can also see this real estate price predictor in action in the Meet Maya demo video of the Maya properties chatbot. The link is in the video description, or you can click on the video here.